All right, we want to take a look at the equation r equals 4 over 2 plus cosine theta and determine, what shape is it? Is it going to be an ellipse, a hyperbola, or a parabola? Find coordinates for all the important points, vertices, foci, equations for the directrix, all that good stuff. What I notice first is that this is close to the general equation r is equal to ED times 1 plus E cosine theta. The problem that we have right now is that that's a 2 right there instead of a 1. So multiply both top and bottom by 1/2 so that you get this written in the correct form for what we need to do. So 2 over 1 plus 1/2 cosine theta. Now I recognize that the foci are on the x-axis because the equation contains a cosine. Of course, we know one of the focal points, one of the foci is going to be at the origin, so that's a given. The other thing that I know is the eccentricity of this equation, E is equal to 1/2. So since that's less than 1, I know we're looking at an ellipse. So all I've got at this point is that we have a focus at 0, 0. Our two foci for the ellipse will be on the x-axis. The number 2 that's in the top of this fraction has to be equal to ED. So if ED is equal to 2 and E is 1/2, then I can find the value of D. D is equal to 4, and I know that one of my directrix equations is going to be x equals 4. So let me start graphing what I know, and that'll help us organize. Whoops. All right, we have a focus here. Come on. There we go. Focus is here. There we go. Now it's responding. Focus is there. At x equals 4, which would be maybe right there. We'll label that. Is one of our directrix lines. Okay, to find the vertices, the points that the ellipse actually has that are going to be on the x-axis, we need to think about it this way. Since we're working in polar form, the two angles, the two values of theta that I want to consider that would get us points that are on the x-axis somewhere would be theta is equal to 0 radians and theta is equal to pi radians. So let's do this. I'm going to let theta be equal to 0 radians. Then solving my equation for r, I'd have 2 over 1 plus 1/2 times the cosine of 0 is 1. So we get an r value of 4/3. So one of our vertices in polar form is 4/3 0. Well, if we're going to talk about points on this graph, it probably makes sense for us to talk about them in Cartesian coordinates, which ends up that is also the rectangular form or the Cartesian form. So if this is x equals 4, let me put some points on this x-axis. Okay, 2, 3, 4, 5. 4/3 is 1 1/3, so we're going to have a vertex about right there. Now to find the other vertex, I'm going to let theta equal pi. Solving the equation for r, r then would equal 2 over 1 plus 1/2 times the cosine of pi, which is -1. And we get a value of r that is equal to -4. So the polar form of the second vertex, polar, is -4 pi. Converting that to Cartesian coordinates, okay, we're thinking about rotating pi radians and then counting out 4 units. So that's the Cartesian or rectangular form would be -4, 0. So there's our second vertex. Vertex, vertex. So 1, 2, 3, 4. There's the vertex V2. Alright, now the center of your ellipse will always be halfway between the vertices. So if we look at the distance from -4 to +4/3, which we can find by taking 4/3 and subtracting -4, the right minus the left, divide that by 2. That's going to tell us how far away from each vertex our center point should be. So let me grab my calculator because I can't just do that in my head. Alright, 4/3 plus 4, divide that by 2, so the distance is 8/3. So if we take -4 and add 8/3, we get -4/3. So the center point is going to be there, which would be -4/3, 0. Okay, now this is kind of all over the place, so I would recommend that when you're working through this, you kind of have to sort of work your way through it. I'm writing a lot of stuff down that you maybe wouldn't put on your paper, but go back and make, if it's something I've got to grade, go back and make a nice neat list of everything that you found. All right, whatever the distance is from the center to the focus, we have to measure that same distance in the other direction. So if we look at that distance is going to be 4/3 of a unit. So then the other focus would have to be 4/3 of a unit in the other direction. So think -4/3 minus another 4/3 is going to be -8/3. So 3, 6, 8, 3, 6, 8. -8/3 would be about right there. So our second focus is going to be right there. Point F2 is -8/3, 0. The distance from the center to the directrix has to be the same as the distance from the center back to the other directrix. So if we think about -4/3 to 4, okay, that's 16/3. So then we want to think about taking that negative x value of -4/3 for the center point and subtracting 16/3 from that. That's going to get us another directrix that's x is equal to -20/3. So that's 6 2/3. So 1, 2, 3, 4, 5, 6. That other directrix line is going to be back here somewhere. X equals -20/3. Okay, then the only thing that's missing is to know how high or how tall this ellipse is going to be. To know that, you've got to find B. We have the value of A. A is the distance from the center to the vertex, and that's 8/3 of a unit. C is the distance from the center to the focus, and that's 4/3 of a unit. Center to focus. And we have an ellipse, so B squared is equal to A squared plus C squared. So 8/3 squared plus 4/3 squared is going to give you about value of B squared, that is 48/9, which, to know where that is, it's about 2.3. Excuse me, that's B. B then would be the square root of 48/3, which is about 2.3 units. So why that's important for me is it tells me how far up and down to count. So 2.3 would maybe be about right there. Negative 2.3 would maybe be about right there. If you're going to sketch your ellipse, then you've got to go through the vertices and make sure you contain make sure you make it wide enough. Now that's really, really messy. Let's do another one. And you kind of just sort of jump in with this and start figuring out things. And I really think that putting it together on the graph is very, very important. This is the first time we have centers that are not at 0, 0. And so we're not necessarily measuring C units from the origin and C and A units from the origin, but we're measuring from the center point. So once you start getting the center, then finding the rest of the values kind of works off the center. Alright, so next example. Given you the equation r is equal to 1 over 2 minus 2 sine theta. Excuse me. Again, you want to start by dividing all the terms of your equation by 2. So actually we have 1/2 on the top of this over 1 minus sine of theta, which is in the form of r is equal to ED over 1 minus E sine theta power. Excuse me, times sine theta. So what I know right now, first of all, I know the value of E is 1, so we are looking at a parabola, which simplifies what we have to deal with a lot. We only have one focus and we only have one directrix. Let's see. Oh yes, it's going to be a conic section where our focus is going to be on the y-axis. No, let me say that right. Because the focus is going to be at the origin, which is the y-axis. The directrix is going to be the line y equals negative d. So once we figure out what d is, then we'll know where the directrix is and we can go from there. Because of the minus, we know that the y value, the equation for the directrix is y equal negative d. So ED is equal to 1/2. E is 1, which means D is equal to 1/2. So our directrix is the line y equals negative 1/2. The focus, there's only one of them because it's a parabola. The focus is the point 0, 0. So the only other thing we've got to figure out to be able to describe all the important parts of this parabola is the vertex. All right, our focus is here. Y equal negative 1/2 maybe is there. So I know my parabola has got to curve away from the directrix around the focus. So the vertex has to be right there. Which is going to be the point 0, negative 1/4. And then if we were going to sketch our parabola, we would just sketch something that bends around the focus and away from the directrix. So if you have a parabola to work with, the work you have to do is significantly less, I think. One last example, and you can kind of get